Hi, this session is about ROXIE and some interesting aspects and behaviors of ROXIE we sometimes come across here in the Risk Solutions group. First up is cold versus warm query performance. Cold is when a query has not been run before. Now, in this case, we have already published a query and copied all the data it would need from Thor to the ROXIE cluster. Also in this case, the ROXIE cluster is idle, except for what I run, to ensure there are no other influences. This ROXIE cluster contains 100 nodes, each with 2 CPUs. Data is available across 4 channels. As you can see, the time for the query when first run is 1464 milliseconds. When we rerun this query on the same server node as before, the time drops to 234 milliseconds, a significant improvement. Additional reruns do not show any further gains. Why the improvement? The improvement comes from ROXIE having some information loaded in its internal node cache, which you can see from the num node cache hits and num leaf cache hits values, and from the OS kernel caching file contents. File data was read from disk on the first run and is kept in memory. So the second time the file is read, it's actually a copy from memory, and it's significantly faster. ROXIE can be warmed up this way by running common queries before it's put into production. One versus many query performance. I want to stress this is highly dependent on the type of queries run and the compute resources of each ROXIE node. Case 1 is perhaps a typical query. The query run by itself completes in 204 milliseconds. The query, when run along with 80 other similar queries at the same time on the 100 node cluster, completes in 208 milliseconds. You can see that running it along with the other miscellaneous queries shows no real degradation in performance. But case 2 shows a much different story. In case 2, we have a query that uses a wildcard search, which involves significant remote work on many other ROXIE nodes. The query itself takes longer to run, as expected, completing in 2577 milliseconds. When this query is run together with the 80 miscellaneous queries from before, it completes in 4406 milliseconds, a measurable slowdown as compared to when it's run alone. But an even more dramatic effect is seen when this query is run together with 50 of these same type of painful wildcard search queries on the cluster. In this case, the query took a long 29 seconds to complete. The point here is that some queries are very resource intensive. In this wildcard search case, each query is adding work to agent threads on almost every other ROXIE node. So each node quickly becomes saturated with agent requests, and these cause all tasks to be slower. Now, it's important to stress that these are 2 CPU nodes. If these nodes had 4 CPUs or 8 CPUs or more, the slowdown would have been much less. It's important to write queries that use indexes and try to avoid wildcard searches and full table scans, and also to be cognizant of the remote resources a query can demand and to size your ROXIE nodes appropriately. Informational log messages. Sometimes you may see in the ROXIE logs messages such as no message collator found using default, and additional data size X on query Y, and keyed limit exceeded. In the first case, no message collator found, I'll go back, usually means messages from agents are received by a server, but the server has either already received the data it needs from another agent on that channel, or the query has thrown an exception and the server no longer cares about the agent data it requested earlier that is now coming back. In the second case, additional data size n usually means an agent is returning data to a server, but there is more data that then can fit into a single packet, which is size 64 kilobytes. So an additional request is made to the agent for the remaining data, and there may be many such messages if there is a lot of data returned. Queries should be written to try and limit remote data needed as much as feasible. In the third case, limit exceeded, it is also an informational note and is simply when remote agent output is more than the ECL limit specified for an operation. Complete log fields. Looking closely at the complete line in a ROXIE log shows some interesting information. The important fields are time of the query, memory used by the query, agent's reply, which is the sum of all agent messages returned to the server, duplicate packets and resent packets. These are new in version 8.0 and are helpful for showing if there are UDP drops or other network issues while a query is executing. Result size is the size of the response sent back to the caller. Num index seeks, scans, and wild seeks, pretty obvious. Num leaf cache, node cache hits and adds, we mentioned before. Num index rows read. Num allocations. Num index accepted. These are rows from an index not post-filtered. Num index rejected. These are rows dropped during post-filtering. These fields can provide very useful information when looking into the performance of a query or when comparing ECL changes. And with HPCC systems version 8.2, there is now a useful new field, time agent wait, to help identify total time spent waiting for remote agents to read, filter, and send back data. Log messages of problems. Sometimes you may see log errors such as get next result timeout or timed out n times waiting for OK to send from node X or failed to get response from agents or input has stalled for X milliseconds or too many active queries. Sometimes these type of errors can occur from an incorrectly coded query requesting too much remote data or insufficient network bandwidth or small socket buffer sizes. But most of the time, these errors usually mean the load on ROXIE is too high, that there are not enough resources to handle the running queries at an expected rate, and timeouts waiting for replies from agents can start to occur. Try to find the query referenced in the log line for these errors and run that query alone on an idle cluster to see if it performs differently. Load, server threads, agent threads, and CPUs. ROXIE is divided into servers and agents. Configuring how many server threads and agent threads are allowed to run and how many CPUs are available are very important settings. If too many queries are sent in a short time to ROXIE, it may become very busy. And then when another query is sent in, ROXIE can respond with too many active queries and reject the query. The number of server threads will affect when this happens. But this isn't necessarily a bad thing. If we allow too many queries to run together, then, as shown above, ROXIE may become overloaded, and then all queries running begin to suffer and take too long, and can experience timeouts waiting for agent replies, etc. Generally, with more CPUs available, these thread maximums can also be increased. Careful monitoring should help determine the best values. Stats. With the test socket utility program, we can send a request to a ROXIE node and get back detailed stats of the activities and queries. we can dump stats on all the activities with the query stats request specifying a query by name. One of the issues with these methods is that they are aggregate for queries run since the last time the stats were cleared. This can make it difficult to view stats for a single query unless you can run the query alone. There is a new stats method added in version 8.2. Adding stats to work unit equals 1 to the query input XML will then collect stats just for that query and save the stats in a work unit, which can be viewed with ECL Watch or Dolly Admin. Looking into the stats of each activity of a query can be very helpful in trying to locate problem areas. ROXIE configuration settings to note. We set some ROXIE config parameters to help with performance and reliability on large clusters. We increase the default socket sizes used, which can really help prevent UDP packet drops. This requires some kernel parameter changes as well. The net.core.rmemmax and wmemmax need to be increased. We use these timeout settings for the 3 queue priorities, and we adjust these UDP timeouts as shown. ROXIE in the cloud. The fundamental change to ROXIE in the cloud is that data storage is now separated from compute resources. This decoupling offers flexibility by allowing new clusters to attach and access the same storage. New configurations can be tried and clusters can scale channels to quickly handle dynamic load changes. The problem, though, is that this decoupling means I/O latency and seek fetch granularity to the separate blob storage is now higher than when the data was on each node's local NVMe SSD disks, and performance is affected negatively. If the aggregate data is divided into enough parts, then the size of each part may be reasonable, such as 40 gigabytes each perhaps, and fit into the available memory of each ROXIE pod. Then once the data is loaded in memory, it would provide performance similar to the current non-cloud systems. An alternative, if there is not enough memory available, or perhaps because it is less costly, is to use Azure Hpc Cache, which is a middle layer, fast network and disk cache with a backend blob storage, accessible from ROXIE pods via standard NFS v3 file interfaces. HPC Cache is well suited to read-based workloads, such as ROXIE. That's all I have for now, and thank you.